Okay, so let's do problem 4. So this is problem 4. It says, it gives you an equation that describes an ellipse, and so first we're going to use implicit differentiation to find y prime. And then after we do that, we are going to find the points on the ellipse where the tangent line has slope 1. And that may turn out to be too hard to put on the actual exam. But let's do it now. It's good practice. So let's just start with A, okay? So I have the equation x squared plus 2y squared equals 1. And now, you know, the idea in implicit differentiation is I take d dx of everything, so both sides. Okay, and you know y prime is what I write. It means the same thing as dy dx. Okay, alright. So when I take d dx of both sides, take the derivative of x with respect to x, and you just, do the derivative in the normal way. Now I have 2 times 2y, okay, and by the chain rule, y prime pops out, because y is secretly some function of x, and this is 0. Alright. So now just solve for y prime. I'm sorry. Even though it should not be doing that, I should be more adept at not letting it trick me. Okay, so now I just solve for y prime. So y prime is equal to minus 2x divided by 4y. And so this is just minus x over 2y. So very similar to what we get when we find y prime for the circle. Let me just write that again. Okay, so minus x over 2y. And that is the answer for part A. Now part B is where the challenge comes in. Okay, so something like part A will definitely be on the exam, but when I started thinking about part B here, I realized it's a little bit more complicated than what I meant to give you, but you can still definitely do it, okay? So we want to know at what points on the ellipse does the tangent have slope 1? Okay, so that's basically looking for the points x, y, where if we look at y prime and we plug in x and y, then what comes out is 1. Okay, so that's what it means. That's what this question means. So we look down here at the equation that we have for y prime. We want to find the values x and y that make that come out to be 1 and are actually on the ellipse. So let's do that. All right. So here's where we're supposed to work on B. So I know that y prime is supposed to be equal to 1, right? And I also know that y prime is equal to minus x over 2y. So minus x over 2y is supposed to be equal to 1. Okay, so now the plan is I can use this formula to solve for one variable in terms of the other, and then I can plug that back into the ellipse formula. Here's the formula for the ellipse. Okay, so that will give me an equation in one variable which I will solve, and then that will put us pretty close to knowing the answer. So I'm going to solve this thing for x just because it's easier. So multiply through by 2y, and I get that minus x, sorry about that, it's my eraser there. So minus x is equal to 2y. So this means x is equal to minus 2y. Alright, so now that I have this, I go back to my equation for the ellipse, because we're only interested in points that actually are on the ellipse. So that means values for x and y that satisfy this equation. X squared plus 2y squared is equal to 1. So just to make sure I'm not crazy, let's go back up and make sure that's the ellipse. Yes. Okay, so now what I'm going to do is substitute this in for x, alright? And that will give me an equation in one variable which I can solve. So what happens when I plug that value in for x? I get 4y squared plus 2y squared is equal to 1, okay? And so this is the same thing as saying that 6y squared is equal to 1. And so from there it's very easy to see that y must be equal to plus or minus 1 over the square root of 6. Okay. Alright, so we're getting very close. If you want to think about a picture of what's happening at this point, oh my god, I can't believe it. I can't even draw a line straight enough that the computer knows I'm even talking about a straight line. It's not completely my fault. This pad is extremely weird. But okay, so here's the ellipse, right? So what we just found is that the y values where the tangent has slope 1, the y values are going to be plus and minus 1 over 6. So here's plus 1, square root of 6. So there's the top one, and here's the bottom one. And now all we have to do is find these points, right? So that's going to be one point where the tangent line has slope 1, and there's going to be another one over here. So all we need to do now is find the x values. Find the x values of these points. Okay, so it's very easy because we can just plug back in. Okay, so what we're going to do now is go back to the equation for the ellipse, and we're going to say if y is this, what are the possibilities for x? So let's set that up. So just plug in plus or minus 1 over the square root of x. Plug in plus or minus 1 over the square root of 6 in for y into the ellipse equation, and I get x squared plus 2 over 6 is equal to 1. Okay, so that means x squared plus 1/3 is equal to 1. And from there it's very easy to see that x is plus or minus the square root of 2/3. Okay, and now we just have to be a little bit sane about which ones we pick, okay? So if we look at, we have x is plus or minus square root of 2/3, and y is plus or minus the square root of 1 over 6. If we look at the picture here, you can see that there are 4 different ways to combine those, right? So this is going to be the positive y and the negative x. This is going to be the positive y and the positive x. This is going to be the positive x and the negative y, and this one's going to be the negative y and the negative x. So these two are not really the answer, right? So at those points it looks like the slope is actually going to be -1. So these are the solutions. So that one right there and that one right there. Okay, so the answer is a set of points. It's the set of points at which the tangent line has slope 1, and the answer is one point is minus square root of 2/3 comma positive 1 over the square root of 6. Okay, so what I just did is I took care of this one. Alright, and now let me do the other one. So this, the remaining one, is the square root of 2/3, and now minus 1 over the square root of 6. Okay, so those are the answers, and that's the end of the problem.